Welcome back to the second instalment of my DIY digital watch build series. You joined me at a very exciting stage. I finally have something working and I can't wait to show you what I've got up to. But first, I'm James from the Printable Watch. If you haven't heard of me, I help you 3D print your own watch at home. Now so far we've built quartz and automatic watches, so I feel like to complete the set we need a digital watch. And this has been a little project I've had running. I'm documenting the full design and development sort of process on the channel. This is the second video. In my first video I run through the specifications and what I'm wanting to achieve out of this project, but in this one I'm going to show you where I've got up to, and it does include a functioning timepiece. We can't quite fit it on the wrist yet, but it does work. Before we get too far into this video, let's have a wristwatch check. So I'm wearing TPW quartz with an Ando Space Cat dial. I think he's doing another run on these. I've been asked a couple of times where I got this dial from, so make sure you check out him. Yeah, he sent me these because he liked what I was doing. Let me know your thoughts on that one. Okay, so now let's head down to the breadboard and let me show you how this thing works and what's going on here. So, as I mentioned in my first video, this is based around the Arduino platform. So here we've got an 18 mega 328P. Now this is the chip that is supplied on the standard Arduino Uno boards. I've got an Uno board here, and although this is a smaller form factor, this is the chip that's driving this board. Obviously this chip is too large to use in the watch, so we will be going for something smaller, like an SMD version, just like the one on this board. So this is the heart and the brains of the watch, this microprocessor. To then keep accurate time, we're using a thing called an RTC chip, which stands for real-time clock. Now this can keep track of time incredibly accurately, and even when you lose power, it has a memory feature. I did say in my first video I wanted to try and avoid using this to save on parts and space, but after some experimenting, the onboard timers on the microprocessor just are nowhere near accurate enough. I'll show up on the screen my little experiment I ran, but they're basically nowhere near accurate enough for a functional watch. So we've got the microprocessor, we've got an RTC chip, then we go to the display under all these wires. This 7-segment display, and basically what we're doing is we're cycling through each digit and displaying the number. If I show you a video in slow-mo, you'll see what I mean by that. But what this means is we don't need another chip to drive the display. We can run it all directly from our main microprocessor. This whole thing is being run off this battery. Now, I did want it to run off standard parts. This is a battery that's going to be able to fit in the back of the watch, so that's why I've gone for a CR2032 battery. We've then got the controls, so we've got a display on, hour set and minute set. Now, the display on was a function I really wanted to avoid using, but unfortunately I was kind of forced to. I set up the watch without this, and basically the amount of power the whole thing uses when in operation will drain the battery within a couple of hours, if we're lucky. So the way I've got around this is by using a sleep function. And basically what this does is it puts the whole device into a sleep state, so everything shuts off, and then when you press this button, it wakes it up and then displays the time, 10 seconds. You can set the time within that time as well, and then it'll fall back asleep again and go into that deep sleep mode. And what this allows us to do is have an incredible amount of battery saving, so it'll last way beyond the target 6 months to a year battery life. And I'm going to be able to demonstrate the power consumption through the multimeter. So I think that's enough talking for now. I'll power up the multimeter so we can see the kind of power we're using. Let's check that's coming up alright on the camera. So I'll show you your first boot up, which is kind of cool. So when this is first booted up, in fact, let's get a better camera angle. Okay, so now we've got a closer angle of the breadboard, so I'm going to run through the startup phase and the power consumption. So hopefully you can see the current draw there. Basically I've got this multimeter running in line with the chip, so we know exactly how much power is being drawn. So I'm going to power it off completely, you can see there. I'm going to power it back on. Upon the initial power up, we get TPW written on the screen, and let's see how much. So we're drawing 7.6 milliamps when we first boot up. Then to get out this screen, we're going to just hit the display button. We've dropped down a little bit, and then you'll see after 10 seconds that screen is going to go off, because now the device has gone into sleep mode. So if I notch this back again, to range, you can see there it's using 0.36 milliamps or 36 microamps. Now if we do a bit of simple math, I'll show it up on the screen, but I've worked out that this is going to equate to over 6 months of battery life, and that's even displaying the time ever so often, which is absolutely spot on. This is exactly where I want it. So how do you operate this thing? Obviously, if we look at the time, it's completely wrong. So to change the time, I'm just going to use these two buttons, which will increment either hour and minutes by 1. Now, my thought behind this is these can be small buttons located on the inside of the watch. So you open it up, tap them to set the time, and then screw it back together, and then the time's fixed, and you just hit this button every time you want to see the time. It's very easy to change that 10-second display time to something a bit shorter or a bit longer, so that's going to be completely up to you how long you want to display the time for. So this is where we are now. Obviously, we've got a working model now. We know this is going to work. What we need to do is shrink it so it can fit inside a watch. And I'm going to show you on my computer where I've got up to with that, because I've made a little bit of progress, but nothing too special. So I'll see you over on the computer. So I'm just going to quickly show you where I've got up to with the PCB design. I've made a bit of progress, mainly so I can see whether this thing's all going to fit onto the space that I want it to. So here we can see this looks incredibly complicated. I've got a bit of a PC, I've got my schematic design here. As you can see, we've got our 4 digits, crystal for this, even though at the moment it's running without a crystal, so I might not use that. Push buttons and the RTC. So if we take that to the actual PCB design, I haven't put in any of the tracks yet, but what I can do is show you this. So this is a sort of 3D model of the movement. So as you can see, we've got our digits, this is our microcontroller, this is our timer chip. If I go around to the back, these 3 pins here are going to be so you can plug in and update the program as and when you want. Obviously this is the battery clip, and then we've got our time setting buttons here. This is just a place marker at the moment for the side switch. I'll either make it pluggable or so that you solder it in. But that's just sort of a setting out thing, nothing's wired up there. It's just so I can make sure this is all going to work. And by the looks of it, it is. And what's even better is I can export this as an STL file and import it into SolidWorks, or I could even print it. So the next stage is I need to finish this design based on what the breadboard's doing. I can then go and get the PCB manufactured, either with or without the components, and put the components in later. I think on the first run, I'm just going to do it without components. It'll save a bit of money and time, and I'll have a go at soldering all these SMD parts on myself. So that's going to be the next video. And that's really where we're up to at the moment. So that's all we've got time for today. I hope you've enjoyed this video. If you have, please make sure to subscribe. If you haven't, comment below what I've done wrong. I hope to see you in the next one, but for now, I'll see you later.